So a very good evening everyone. Myself Prateek Mishra and I welcome you all to the YouTube platform of IMS Gate Academy. Just quickly reply audio video is clear, everything is good, so that I have a confirmation. Kindly reply audio video is clear, everything is good. Quickly just confirm the audio video so that we can start the session. Just quickly confirm audio video is clear, everything is fine. Good evening Piyush, audio video is clear. Just quickly confirm audio video is clear. Yes sir, okay. So thank you so much for confirming this audio video now. My dear, a very good evening Akshat, very good evening. My dear students, I hope you have enjoyed the last session, showing some energy. This time also I am just expecting the same energy. In fact, I want more energy because today I am in a mood to finish all the remaining portion of environmental engineering that requires some serious temperament, some serious mindset from both the sides. So the kind of energy people will show, it will literally going to motivate me in the same direction to complete the remaining things in a matter of 3 hours. In the previous session, we have talked about the raw water engineering and till sedimentation analysis. We have discussed the important varieties of questions and we have also discussed few of the concepts and I have given you the overview. We were going to do the same thing in this session as well. We will continue from that process onwards and whatever will be the remaining portion is left, we will going to conduct some questions and I am just expecting same answers from you. So my dear, before moving ahead, this year onwards, we have launched this course called Test Series Plus, where we are providing you with the question bank along with the test series and it is offered to you at a discounted price of 20% and it's a limited offer course. Chalo, moving ahead with this, in the previous session, we have finished till sedimentation. Sedimentation is a process in which the suspended solids settle under their own weight. But my dear, what if the raw water contains some fine suspended solids? If we design the sedimentation tank for the removal of fine suspended solids, then the detention time we need to provide for the sedimentation tank may come out very huge. So in such cases, where the water contains fine suspended solids, we prefer coagulation aided sedimentation. So the first process is coagulation and flocculation. Coagulation is the fast mixing where the coagulant is induced, which neutralizes the negative protective charge present over the surface of the fine suspended solids so that they can come together. And flocculation is a process where the sticky precipitates revolves around the entire volume of the tank and over the surface of the sticky precipitate, all these fine suspended solids will going to attach to form a larger size of solid which can settle out easily. So here are some of the things. So coagulation is fast mixing whereas flocculation is slow mixing. In order to carry out coagulation, we add some coagulants, namely alum, copperas, chlorinated copperas and sodium aluminate. The very important thing here is, good evening, very good evening. Important thing here is when we add alum reacts with the alkalinity present in the water to form the sticky precipitate. And this sticky precipitate is revolved in the flocculation tank for the attraction of all the fine suspended solids over its surface. So all the fine suspended solids get absorbed over the surface of this sticky precipitate. Important thing here is alum will react with the alkalinity present in the water to form sticky precipitate. Alum increases the permanent hardness and acidity of the water. The working range of alum is 6.5 to 8.5 pH. Similarly, copperas also reacts with the alkalinity present in the water to form sticky precipitate of FeOH whole thrice. It imparts color and increases the permanent hardness. Table is very important, my dear. You can expect a multiple select question from this table. So I have just summarized the entire theory for you. The working range of this copperas is 8.5 pH and above. The next coagulant is termed as chlorinated copperas, and again this chlorinated copperas will react with the alkalinity present in the water to form the sticky precipitate of FeOH whole thrice. Again this chlorinated copperas imparts color and increases the permanent hardness of water. The important thing about chlorinated copperas is the working range of this chlorinated copperas is very wide. It works in the pH range of 3.5 to 7 and above 8.5. That is the advantage of this chlorinated copperas over other coagulants. My dear, here you can see there is a salt of aluminium and these two are the salts of iron. Salt of aluminium will form light flocks. Salt of iron will form more dense flocks or more heavy flocks. Heavy flocks are easy to settle as compared to aluminium flocks, but since these copperas provides color to the water, that is why these copper salts are used for the treatment of sewage, whereas this aluminium salt, that is alum, is used for the treatment of raw water. Last one is called as sodium aluminate. The important thing about sodium aluminate as a coagulant is it reacts with the hardness present in water. So the above three listed coagulant reacts with the alkalinity. Sodium aluminate reacts with the hardness present in water. It reduces the hardness, but due to high charge of sodium aluminate, it is very costly. It is not used for the treatment of treating community water. In fact, it is used for the treatment of treating boiler feed water or industrial water. So this is the table regarding coagulant. Moving ahead with this, one very important fact you need to remember here is 1 gram of alum will react with 0.45 gram of alkalinity as CaCO3. 1 gram of alum will react with 0.45 gram of alkalinity as CaCO3 to form 0.234 gram of sticky precipitate. A very, very important fact that can help you to solve the question directly without any confusion. What is the fact? 1 gram of alum will react with 0.45 gram of alkalinity as CaCO3 to form 0.234 gram of sticky precipitate. This already I told you that alum is used for the treatment of water supplies and iron salts are used for the treatment of sewage. And if I am talking about iron salts, I am talking about copperas and chlorinated copperas. Copperas and chlorinated copperas and chlorinated copperas and chlorinated copperas. These are iron salts. And your sodium aluminate is used for the treatment of boiler feed water. Now my dear, the intensity of mixing, just keep showing your love my dear in the chat box. वो चलता रहना चाहिए, that should not stop, so that even I am equally motivated that you people are also enjoying the same kind of session. Another thing which is very important regarding intensity of mixing, it is measured by a factor which is called as temporal mean velocity gradient, which is equal to under root P upon mu into V, where P is the power provided to the shaft, mu is the dynamic viscosity of water, and V is the volume of the tank where this flocculation is taking place. So temporal mean velocity gradient basically decides what is the intensity of mixing. Then you have flocculation, which is termed as slow mixing. I already told you that whatever sticky precipitate is formed in the coagulation process, now this sticky precipitate is revolved in the entire volume of the flocculation tank so that the fine suspended solids can get adsorbed over the surface of this sticky precipitate to form larger size of suspended solids, and it can get settled out easily in the following sedimentation process. Moving ahead with this, this is a very fantastic question. You can just quickly try. You have just 1 minute of time, my dear. Just keep on answering your answers quickly. 1 minute of time for this easy question, which will help you to revise the concept. Go for it. Just 1 minute of time. We have to solve a lot of questions, so be quick on your calculations today. Keep answering, keep answering. Keep answering. Akshat, Piyush, Sarla, keep answering this. Keep answering this. And keep the chat box ticking. Quickly, quickly, quickly. This should not take more than 1 minute. So question says that a flocculation tank contains 2000 meter cube of water which is mixed using paddles at an average velocity gradient. G is given to you as 100 per second. The water temperature and the corresponding dynamic viscosity are 30 degrees Celsius and 0.798 into 10 raised power minus 3 Newton second per meter square. The theoretical power required to achieve the stated G value is. So my dear, we know this temporal mean velocity gradient G is under root of P divided by mu into V. P is the power, so I can write down the expression for power. Power is equals to G square into mu into V. You have to simply substitute all the values, all the answers you can give me quickly, right? Substitute all the values. So power of the shaft in watts will come out as G is given to you as 100 square. G is given as 100. So this is 100 square. Mu is given to you as 0.798 into 10 raised power minus 3. And the volume of the tank is 2000 meter cube. Just substitute all the values and get me the answer of this G. Oh, sorry, power. Quickly calculate this and tell me the answer. This will be how much? So this will be 10,000 multiplied by 0.798 into 2000 divided by 1000. So this will be 1.596 into 10 raised power 4. Just check this answer. So this is 100 into 100 into 0.798 into 2. So this is 1596, sorry. Yeah. So power is equals to 15960 watts. You have to report the answer in which units? You have to report the answer in kilowatts. So what will be the answer? Answer will be 15.96 kilowatts. So the power required is 15.96 kilowatts. This will be the power required, 15.96 kilowatts. Let's move ahead with this. Try this next question. The next question is again a very simple question. Please try this, which will help you to revise this concept quickly. Again, just 1 minute of time for you. Go for it. Go for it. Go for it. Go for it. Please go for it. So question says that a surface water treatment plant operates round the clock with a flow rate of 40 meter cube per minute. So discharge is given to you as 40 meter cube per minute. Let me write this. Discharge is given to you as 40 meter cube per minute. Okay, sir. Then question says that the water temperature is 15 degrees Celsius and the jar testing indicated that an alum dose of 30 milligram per liter with GT as 4 into 10 raised power 4 for producing optimum result is required. Now they are asking the alum required for 30 days in kgs will be. In simple words, they have given you the alum dose for 1 liter of water. So in 1 liter of water, 30 milligram of alum is required. Now they are asking how much alum is required in next 30 days. Let's calculate this. So alum dose required is 30 milligram per liter. So first of all, you can calculate alum required in 1 minute. Alum required in 1 minute. Alum required in 1 minute is 30 milligram multiplied by this much amount of water. So this is given to you in meter cube. So convert this into liters. So this will be 40 into 10 raised power 3 liters. So this much amount of alum is required in 1 minute, and this answer is in milligram. Okay. Now you have to calculate alum required in 30 days. So just count number of minutes in 30 days and multiply with this value to get the value of alum required for 30 days. Please do the calculation and tell me the answer. Alum required in 30 minutes. Alum required in 30 days is equal to, so alum required in 1 minute, that is 30 into 40 into 1000 multiplied by number of minutes. So my dear, one day has how many minutes? So 1 hour has 60 minutes, 60 into 24 into 30. These are the number of minutes which are there in 30 days. Okay. Now this answer will come in milligram. You want the answer in kgs. So you need to divide this by 10 raised power 6. Divide this by 10 raised power 6. So you will get the answer in kgs. Please tell me the answer in kgs quickly. This will be the amount of alum required in kgs. Please do the calculation and tell me the answer in kgs. Please tell me this answer. So this will be, I think, 51840 kgs. So this much amount of alum will be required in 30 days if alum dose is 30 milligram per liter. Very good, Piyush. 51840 kgs. Very good. Chalo, moving ahead with this. Okay. So after this, the next process is termed as filtration. My dear, filtration is a process of removing fine suspended solids from the water. Filtration is carried out by the units termed as filters. Filters are of two types, gravity filters and pressure filters. If the amount of head required by the water to flow through the filter medium is provided by the standing height of water column above the filter medium, then it is called as gravity filter. If the amount of head required by the water to flow through the filter medium is applied artificially by applying the pressure, then it is termed as pressure filter. Which filter is used to treat community water? So gravity filters are used to treat community water, because if you start using pressure filters, then huge amount of cost will be involved in creating the pressure for treating community water. Now sir, gravity filters are again of two types, slow sand filter and rapid sand filter. Always keep this one thing in your mind. Whenever you are comparing these two filters, compare by the size of filter medium. In slow sand filter, the size of the filter medium particle is less as compared to rapid sand filter. So this answers your one very simple question, ki which filter has more efficiency. So obviously, since size of the filter medium particle is less for slow sand filter, therefore efficiency of filtration is more for slow sand filter as compared to rapid sand filter. Second, in which water you can treat more amount, in which filter you can treat more amount of water in one day. So again answer is connected with the size of the filter medium particle. If size of filter medium particle is less, a specific surface area of filter medium particle will be more. So when the water will pass through the filter medium, frictional resistance offered by the filter medium will be more. If frictional resistance offered is more, then the quantity of water treated by the filter medium will be less. So rate of filtration for slow sand filter is less as compared to your rapid sand filter. So which filter can treat more amount of water? Rapid sand filter can treat more amount of water, and that is termed as rate of filtration. Which filter has high efficiency of treatment? Means which filter can remove more particles from the water? So sir, slow sand filter has more efficiency of treatment. It can remove more particles from the water. Next is slow sand filter, the impurities will be present in the upper layer of the filter medium. So basically, if you have to clean this filter, you have to simply remove 1.5 to 3 centimeter of the top layer, especially of fine sand layer which is present at the top. But in rapid sand filter, the impurities infiltrates throughout the depth of the filter medium. Hence, this rapid sand filter is cleaned by the mechanism of backwashing. Okay, sir. Next, so cleaned by removing 1.5 to 3 centimeter of the layer of the filter medium. Whereas in this rapid sand filter, it is cleaned by backwashing. Now there are other other things related to rapid sand filter. First of all, when you do the backwashing, the filter bed will going to expand, right? The porosity of the filter bed will going to increase. So porosity of the expanded filter bed is equal to VB by Vs raised to the power 0.22. VB is the backwash velocity and Vs is the settling velocity of the filter medium particle. Second thing, when the water flows through the filter medium, this water will experience the head loss, which is calculated by the expression HL is equals to D into 1 minus N into G minus 1, where D is the depth of the filter medium, N is the porosity of the filter medium, and G is the specific gravity of the filter medium particles. Now there is one very important thing here. Very good, Harish. There is one very important thing that you should remember, that the head loss of water while flowing under normal operation and during backwashing is same. Means when the water flows through the filter medium during normal operation, the amount of head loss that will occur, the same amount of head loss will occur when backwashing is taking place. So this is a very important finding here, that the head loss occurring through the filter medium is same whether the bed is expanded or not. So I will just write down head loss of expanded bed, head loss through expanded bed, head loss through expanded bed, head loss through expanded bed. When the bed will going to expand? During backwashing. Head loss through expanded bed is equal to head loss through unexpanded bed, is equal to head loss through unexpanded bed. Please remember this, because this will going to help you to do a very good quality question asked from this area. Now sir, what is head loss through expanded bed? So head loss through expanded bed is equal to head loss through expanded bed is equal to D dash. D dash is the expanded depth of the filter bed into 1 minus N dash. N dash is the porosity of the expanded bed into G minus 1. This is the head loss through the expanded bed, right? And you have to simply equate these two and calculate if any value is asked. Now let's see some question. Okay, so this is a question. Please try this question. Have 2 minutes of time. Go for it. Go for it. Have 2 minutes of time. Go for it. Chalo. Have 3 minutes of time. Go for it. But this time I want answer from all of you. Piyush, Harish, Kirtan, Chandan, all of you. Go for it. Go for it. Keep answering. Go for it. Keep answering the question. Yeah, good evening, Richa. Good evening. Please answer the question. Please answer this question. Yeah, it's okay. Piyush is saying 172.8. Okay. All of you just quickly answer this. 4 filter beds are required. Very good, beta. Very good. Keep answering this. All of you quickly answer this. Keep answering, keep answering. Now, these are like some of the favorite varieties of questions which are asked in environmental engineering. I'll tell you the reason why. Question says that a city is going to install a rapid sand filter after the sedimentation tank. Use the following data. Design loading rate of the filter. Now, sir, we never heard about this word, design loading rate of the filter. But while dealing these things in the class, I always tell you to observe the units. You can learn so many things from the units that these terms may not explain you. Now, from the units, what I can understand is 300 meter cube per day of water can be treated by 1 meter square area of filter bed. That is what this unit is telling me. 300 meter cube per meter square per day means 300 meter cube per day of water I can treat using 1 meter square of area. Very good, Kirtan. Very good, beta. Very good. So, design loading rate is given to you as 300 meter cube per meter square per day. And how much amount of water you need to treat? You need to treat this much amount of water. 0.6 meter cube per second. So, first of all, calculate the total area of the filter bed required. So, total area of the filter bed required is, so area of filter bed required is, design discharge divided by the rate of filtration. Design discharge by rate of filtration, and rate of filtration simply means how much amount of water you can filter using 1 meter square of filter area. So, design discharge is given to you as how much? It is given to you as 0.6 meter cube per second. Convert this into meter cube per day. So, this is 0.6 multiply by 60 into 60 into 24. This will be your discharge in meter cube per day. And rate of filtration, this is your discharge in meter cube per day. And rate of filtration is already given you in meter cube per meter square per day. So, this is 300 meter cube per meter square per day. So, this meter square will go up, meter cube per day will cancel out, and you will get the answer in meter square. Please tell me this answer of surface area, filter area, sorry. Please tell me this answer. So, this will be 0.6 into 60 into 60 into 24 divided by 300. So, this will be 172.8 meter square. 172.8 meter square. Now, sir, area of one filter bed is 50 meter square. Area of one filter bed is 50 meter square. So you can calculate number of filter beds. Number of filter beds are total area of filter bed, that is 172.8, divided by area of one filter bed, which is 50 meter square. So just do 172.8 divided by 50. That will come out as 3.456. So 3.456 means you need to provide approximately 4 beds. You need to provide approximately 4 filter beds. So Piyush Kirtan has answered it absolutely correctly. So absolutely 4 beds are required. Chalo, moving ahead with this next question. This is the next question. Please go for it. Again, a very, very important variety of question that can be framed from this segment. Please go for it. 3 minutes of time for you. Go for it. This question should not require 3 minutes, but still I am giving you. Go for it. Go for it. Sir, should we include one standby as well? Not required, Piyush. As of now, not required. So you have to just provide 4 filter beds. 4 filters you require. Means they are asking how many operational filters you require, right? So operational 4 filters are required and 1 will be standby. Go for it. Again, a very important variety of question. Please go for it. And all of you keep commenting your answers. It is required. Keep answering, keep answering. Keep answering. Do it, do it. Please go for it. So question says that a 0.9 meter deep bed of sand filter, length 5 meter and width 3 meter, is made of uniform size particles, diameter 0.3 mm, specific gravity 2.65, with a bed porosity of 0.38. So my dear, normal filter, unexpanded bed has a porosity of 0.38. Let me draw this diagram. So unexpanded bed, this is the unexpanded bed, and this unexpanded bed has a porosity of 0.38. So N here is 0.38. Porosity of unexpanded bed is 0.38. And the depth of this filter bed is given to you as 0.9 meter. So D is given to you as 0.9 meter. Now when this bed will going to undergo backwashing. So this is the unexpanded bed. This is unexpanded bed. When this bed will undergo backwashing, the depth of the bed will going to increase. Okay, sir. So this is the expanded bed. This is your expanded bed. So during backwashing, the depth of the filter will going to increase, and so as the porosity. So the depth of the filter during backwashing is D dash. So depth of the filter bed during backwashing is D dash, and this D dash they are asking. Do you know the porosity here? N dash. You don't know the porosity, but data is given to you. You know the backwash velocity, and you also know the settling velocity of the medium particles. Let's check this out. So backwash velocity is given to you as, backwash flow rate is given to you as, okay, backwash flow rate is given to you as 3.6 meter cube per minute. So backwash flow rate is given to you as, 3.6 meter cube per minute. Now using this backwash flow rate, you can calculate the backwash velocity. So backwash velocity is nothing but backwash flow rate divided by the plan area. Of this filter medium. So for plan area of filter medium, again the data is given to you. The length is given to you as 5 meter and the width is given to you as 3 meter. So you can calculate the backwash velocity. So backwash velocity will be equal to backwash flow rate, which is 3.6 meter cube per minute. I am telling you, units are very important. Don't play with the units. Always write them down. And plan area will be equal to 5 into 3. That is your plan area. 5 into 3. And this will come out in meter per minute. Please do the calculation and tell me what will be the backwash velocity. So this will be 3.6 divided by 15. So this will be 0.24. VB is equals to 0.24 meter per minute. Because plan area is in meter square will cancel out and you have backwash velocity in meter per minute. Now next, the terminal settling velocity of the medium particle is given to you as 0.05 meter per second. So Vs is given to you as 0.05 meter per second. Vs is 0.05 meter per second. Okay. So you can convert this backwash velocity in meter per second, and then you can use these two to calculate the porosity of the expanded bed. So porosity of the expanded bed is equal to Vb by Vs raised to the power 0.22. Make sure that units of both the velocities are same. So what I will do is, I will write like this. This will be 0.24 divided by 60. So this will be in meter per second divided by 0.05 raised to the power 0.22. Get me the value of porosity of the expanded bed. What will be the porosity of expanded bed? Very good, Piyush, very good. Calculate this and tell me the porosity of the expanded bed. So this will be 0.24 divided by 60 into 0.05 raised to the power 0.22. Just get me the value of porosity of the expanded bed. All of you quickly answer this. Porosity of the expanded bed is 0.5736. So porosity of expanded bed N dash is 0.5736. So porosity of expanded bed is this. Now sir, how to calculate D dash? For calculating D dash, we know one fact that head loss through the expanded bed is equal to the head loss through unexpanded bed. So I will write down head loss through expanded bed, is equal to head loss through unexpanded bed is equal to head loss through unexpanded bed. Now, sir, what is head loss through expanded bed? Head loss through expanded bed is equals to D dash into 1 minus N dash into G minus 1. And this head loss through unexpanded bed is D into 1 minus N into G minus 1. Right? Already you know the value of G. You know the value of N dash, you know the value of N. So, first of all, this G minus 1 and G minus 1 will going to cancel out because the filter medium particle is not changing, so specific gravity will be same. D dash you need to find out. So, I will write down D dash into 1 minus 0.5736. I think this is the porosity, 5736, yes, is equal to D, which is 0.9 into 1 minus porosity of unexpanded bed is 0.38. Calculate this value and tell me the value of D dash. All of you please do the calculation and tell me the value of D dash. All of you just do this calculation and tell me the value of D dash. So, this will be 1 minus 0.38 into 0.9 divided by 1 minus 0.5736. So, I think this will be 1.31 meters. Just confirm your answers. Are you getting the same answer D dash as 1.31 meters? Kindly confirm yes or no. Do it, do it. Kindly confirm this. It is 1.31 meters. .308 can be treated as 1.31 meters, right? Okay. So, moving ahead with this, next thing after this is, after filtration, the next process is softening, where you remove the hardness from the water. Now, for doing softening, you have basically three major processes. First one is lime soda process, second one is zeolite method, third one is demineralization. In lime soda process, you will not get zero hardness water, whereas in zeolite method and demineralization method, you will get zero hardness water, right? So, all the details we have discussed in the class. Now, we talk about the disinfection. The very important treatment given to raw water is disinfection. Now, first of all, sir, what is disinfection? In order to understand disinfection, first you need to observe that when we talk about raw water, it contains disease-causing microorganisms and non-disease causing microorganisms, which are termed as coliforms. The process of killing or removing only disease-causing microorganism is termed as disinfection. And the process of removing both disease-causing and non-disease-causing microorganism is termed as process of sterilization, right? So, disinfection is a process of killing only disease-causing microorganism. Now, sir, this disinfection is carried out using two methods, either physical methods or chemical methods. When we talk about physical method, we talk about treatment by boiling or treatment by UV radiations. When we talk about treatment by chemical methods, we talk about treatment by the use of acids and alkalis, by the use of heavy metals, by the use of metals like copper, gold, silver. Then we talk about treatment by using oxidizing agents. So, oxidizing agents like KMNO4, ozone, chlorine, bromine, iodine can be used to disinfect the water. So, if you carry out disinfection using ozone, so basically ozone destroys the cell wall of the microorganisms, due to which all the essential fluid flows out and leads to the killing of microorganism. When we talk about treatment with potassium permanganate KMNO4, KMNO4 increases the permeability of the cell walls, due to which all the essential fluid flows out and leads to the killing of microorganism. But these two processes, especially ozone gives you pleasant taste to water, but ozone is again very difficult to handle. And second one is it is highly reactive. So ozone does not take care of future recontamination. Because of high reactivity, ozone does not take care of future contamination. So this is highly reactive. This is highly reactive. This is highly reactive and does not take care of future recontamination. Does not takes care of future recontamination. But ozone imparts pleasant taste to water. A good taste to water is provided by ozone. Potassium permanganate is basically used to treat well water in the villages. It is not used in the mass scale because the detention time required for the killing of microorganism in potassium permanganate is usually 24 hours. It requires a lot of time. So majorly we go with the treatment with chlorine. Chlorination is the major process of disinfection for community water. First of all, chlorine can be added in any form, solid, liquid or gas. It is available in all the three forms. Now sir, what does chlorine does? Chlorine actually destroys the enzymes. Chlorine actually destroys the enzymes which are responsible for the metabolism of microorganism and leads to the killing of microorganism. The moment you will add chlorine in water, chlorine reacts with water to form hypochlorous acid. And this hypochlorous acid dissociates into hypochlorite ion. So basically when you add chlorine in water, chlorine will be available in three forms. Free chlorine, Cl2, then you have hypochlorous acid, HOCl, and OCl minus, that is hypochlorite ion. All these three forms of chlorine are termed as free forms of chlorine. And all these three forms of chlorine are capable of carrying out the disinfection. Out of these freely available forms of chlorine, hypochlorous acid, HOCl, which acid? Hypochlorous acid has the highest tendency and capacity to carry out disinfection. In fact, the most disastrous disinfectant in this freely available form of chlorine is hypochlorous acid. You can see here that I have written the pH range. If pH of water is less than 5, then free chlorine will be predominating. If pH of the water is between 5 to 7, then hypochlorous acid will be predominating in the water sample. If pH of the water is between 7 to 8, then hypochlorous acid and hypochlorite ion, HOCl and OCl minus ion will be predominating in water. And if pH of the water is less than 8, then hypochlorite ion will be predominating. Now I already told you that out of these three freely available forms of chlorine, HOCl is the most destructive disinfectant. Hence, for carrying out the disinfection, we maintain the pH of water in the range of 5 to 7. Apart from this, chlorine also reacts with the ammonia present in the water to form freely available chlorines. Chlorine reacts with the ammonia present in water to form chloramines. Monochloramine, dichloramine and nitrogen trichloride. These are three chloramines. So you have unichloramine, NH2Cl, unichloramine, then you have dichloramine, NHCl2, and then you have nitrogen trichloride, NCl3. These three are termed as combined forms of chlorine. These are termed as combined forms of chlorine. So in total, when you are adding chlorine to water, there will be 6 different forms of chlorine which are available. 3 as freely available chlorine and 3 as combined forms of chlorine. Out of these 6 different forms of chlorine, HOCl is the most destructive disinfectant. Second thing, out of chloramines and freely available chlorines are more destructive disinfectant than these combined forms of chlorine. After this, we have one law which is termed as Chick's law, which tells us about the number of microorganisms present in water after time t. Basically, it is useful in calculating the disinfection time required. So, Nt is equals to N0 into e raised to power minus k into t, where Nt is the number of microorganisms present in the water after time t, N0 is the initial number of microorganisms present in the water, and then you have E. raised to the power minus k into t, where k is called as disinfection constant and t is the time available to carry out the disinfection, right? Apart from this, we have one more law. We have one more law which is termed as Watson's law. I will write here. We have one more law which is termed as Watson's law. Which is termed as Watson's law. Now, what does Watson's law states? Watson's law states that the time required to carry out the disinfection multiplied by the concentration of disinfectant raised to the power n is a constant. T into C raised to the power n is a constant, where T is the time required to carry out disinfection, C is the concentration of the disinfectant, and n is a constant which depends, n is basically disinfection constant, which depends upon the type of microorganism present in the water. So this is again a very important term here. Chalo, let's move ahead, see a question. Please try this question. Have 2 minutes of time and try this question. Please try this question. Keep answering, all of you. Keep answering, please. Keep answering. Please do the calculation. Please do the calculation. Piyush is saying 19.935 minutes. Okay. Chalo, the question is simple. Question says that chlorine is used as a disinfectant in a municipal wastewater treatment plant. It achieves 50% disinfection. It achieves 50% disinfection efficiency measured in terms of killing the indicator microorganism E. coli in 3 minutes. The important term here is 50% efficiency, 50% killing. 50% killing in 3 minutes. 50% killing in 3 minutes. Highlight is 50% killing in 3 minutes. The minimum time required to achieve 99% disinfection efficiency is, means they are asking in how much time 90% killing will take place. In how much time 90% killing will take place. It's a very simple question. In how much time 90% killing will take place? Now check this out. 50% killing. What do we mean by 50% killing? 50% killing means after 3 minutes, the number of microorganisms which are present in the system is equal to 50% of N naught. Number of microorganisms present in the system is 50% of N naught. Please do it. So you have Nt is equals to N naught into e raised to the power minus k into t. So Nt here is N naught by 2. 50% of N naught is nothing but N naught by 2. This is equal to N naught into e raised power minus k into 3 minutes, right? Now, if the student is not our student, he will first going to calculate the value of k, and then he will going to find out the value of t. But since the student is my student, so what my student will do? My student will first of all frame another equation of 90% killing. So 90% killing is after time t, the number of microorganism present is 90% of N naught. Okay, sir. Nt is equals to 90% of N naught. So I will again use this. Nt is equals to N naught into e raised power minus k into t. This time we don't know, and disinfection constant also we don't know. So Nt is equals to 0.9 times of N naught is equal to N naught into e raised power minus k into t, right? Quickly cut out this N naught and N naught from either side. So what you are left? You are left with 0.5 is equal to e raised power minus k into 3. And here when you cut out this N naught and N naught from either side, you are left with 0.9 is equal to e raised power minus k into t. Now what I will do is, I will simply take the log on either side to the base e. So natural log of 0.5 is equal to minus 3k. Similarly, natural log of 0.9 is equal to minus k into t. Sir, simply divide equation 1 with equation 2 and you will get the answer of k. Please do it. Always find out the easiest way of doing the calculation. Never go with the complicated way, right? Specifically when you have these type of comparative questions asked. Simply divide these two equations and get me the value of t. So you have natural log of 0.9 by natural log of 0.5 is equal to minus k into t divided by minus 3k. So k and k will going to cancel out. Without calculating k, you will get the value of t. Please tell me the value of t. This minus and minus sign will also cancel out. So t is equals to 3 times of natural log of 0.9 divided by the natural log of 0.5. Please do the calculation quickly. Tell me the value of t. Piyush has answered it. 99% efficiency or 90% efficiency? Oh, 99% efficiency. I did this for 90% efficiency. Yaar. Chalo, no problem. Let me just do this quickly. So nothing will going to change, only one data is changing here. So 99% killing efficiency. So this will be 99. Okay, one more thing. 99% killing efficiency means the number of microorganisms left here will be 1%. So this will be 1 by 100. So this will be 0.01. This will be also 0.01. This will be also 0.01. And this will be also 0.01. This will be also 0.01. Number of microorganism left. This is number of microorganism left. Sorry, I did a mistake. Sorry. 99% means only 1% will be present in the system. Yes, absolutely correct. In flow, in too much excitement, I make these kind of mistakes. So please avoid this and just do this calculation. So the number of microorganism left here is 1% of N naught, right? Similarly, if 50% is killing there, the number of microorganism left in the system is 50% of N naught. Please do this calculation. So this will be 3 into natural log of 0.01 divided by natural log of 0.5. So 3 into natural log of 0.01 divided by natural log of 0.5. So this is how much? So this is 19.93 minutes. Yeah, this is 19.93 minutes is the correct answer. Very good. 19.93 minutes is the correct answer. Okay. Chalo, moving ahead with this, try this question. A very, very good quality question. Please try this. You will find not just in GATE examination, in so many exams you find this question. Go for it. 2 minutes of time for you. Go for it. Go for it, go for it. Go for it quickly. Very good. Piyush is answering 8.89 meters. Okay. The question says that a wastewater is to be disinfected with 36 milligram per liter of chlorine to obtain 99% kill of microorganism. So efficiency of disinfection is given to you as 99%. The wastewater flow rate is 4 meter cube per hour and K is 0.23 per minute. If depth and width of the chlorination tank are 1.5 meter and 1 meter respectively, the length of the tank is. Now sir, first of all, how to calculate length of the tank? You already know the depth, you already know the width. So by any means, if I can calculate volume of the tank V is equal to length into width into height. Okay. And out of all these three values, I know the value of B and H, and volume I don't know. Now sir, how to calculate volume? Volume of the tank is equal to discharge multiplied by the detention time. Detention time is the time for which water stays in the treatment unit. Now sir, how to calculate this detention time? Now for how much time the water needs to stay in the disinfection unit? So the time required can be calculated by using this. You require 99% killing of microorganism, and the time required for killing 99% of microorganism can be calculated by using Chick's law. So I will write down by Chick's law. By Chick's law, NT is equal to N naught into e raised power minus K into T. Okay. So if 99% killing has happened, then the number of microorganisms that are left in the system will be 1% of N naught. So NT will be 1% of N naught. So I will write down 1 by 100 of N naught will be left in the system after time t is equal to n naught into e raised power minus k is given to you as 0.23 per minute. So when you calculate this time will also come out in minutes, right? So this n naught and n naught will going to cancel out. Get me the value of this time. Please calculate this time. And this will be the detention time for which water will stay in the disinfection unit. Because we want water to stay for this much time so that 99% of killing can be taken care by this chlorine. Please do this. Calculate this time. So this will be natural log of 0.01 divided by 0.23. So this will be 20 minutes. Just confirm this, 20.02 minutes. Yeah. So this T is coming out as 20.02 minutes. Okay. And this T is the detention time for which water will stay in the treatment unit. Calculate this. This discharge is given to you in meter cube per hour. So convert this into hours. So in how many hours this is? This is 20.02 divided by 60. Just tell me this answer of hours. 20.02 divided by 60. So this will be 0.333 hours. Just check. This will be 0.3337 hours. 0.3337 hours, right? Now just calculate the volume from here. So volume is equals to design discharge, which is 40 meter cube per hour, multiplied by the detention time, which is 0.3337 hours. So this volume will come out in meter cube. Please do this into 40. So this will be 13.35 meter cube. 13.35 meter cube, and this should be equal to L into B. B is given to you as how much? The width of the tank is 1 meter and depth is 1.5. So 1 into 1.5. From here you can calculate length of the tank. Please calculate this. So 13.35 divided by 1.5. So this will be 8.9 meters. This will be my final answer of length of the tank, which is 8.9 meters. All of you are getting the same answer? This is 8.9 meters, right? Okay. Let's move ahead with the next question. Try this, a very good quality question. This is, I think, also a GATE previous year question. Please try this. 3 minutes of time for you. Go for it. Any answers? Take, extend just 1 minute more, extend it for you, go for it. Go for it, go for it. It's a very good quality question. I want all of you to try this. Go for it. Go for it. Please go for it. It's a very good quality question. Please go for it. And keep commenting your answers. So let's see this. The question says that a 16 mld of water is flowing through a 2.5 kilometer long pipe with a diameter of 45 centimeter. Okay, first visualize this. 2.5 kilometer long pipe with a diameter of 45 centimeter and water is flowing at a rate of 16 mld. The chlorine at the rate of 32 kg per day is applied at the entry of this pipe so that the disinfected water is obtained at the exit, right? So first visualize this pipe. This is a pipe. Length of the pipe is 2.5 kilometers. And the amount of discharge that is applied over the pipe is 16 mld. This is the pipe. The amount of discharge applied is 16 mld. The area of this pipe is, diameter of the pipe is, I think, given to you as 45 centimeter. This diameter is given to you as 45 centimeter. And the length of the pipe is 2.5 kilometers. Okay. You are applying chlorine here. Chlorine is applied. What is the chlorine dose that is applied? 32 kg per day. So here you are applying 32 kg per day of chlorine. 32 kg per day of chlorine you are applying. And when the water comes out from the exit, it is free from these microorganisms. It is totally disinfected. So this is free from microorganisms or free from pathogens. Now what the question is saying that for the same pipe, for same diameter, same length, if the discharge is increased from 16 mld to, I think, the increased discharge is 22 mld. If the discharge is increased from 60 mld to 22 mld, in order to carry out complete disinfection of water, how much amount of chlorine you need to add? So now the discharge that will be flowing in the pipe will be 22 mld. Area is same, means diameter of the pipe is still same. It is 45 centimeters. Length of the pipe is same, 2.5 kilometers. Now you need to find out how much amount of chlorine you need to apply here so that complete disinfection is carried out. Now tell me one thing, why the chlorine dose will change? What is the reason of change in chlorine dose? Initially when the discharge was less, time available with the water to flow to the other end is more. But now since discharge is more, so velocity will be also more because area is constant. So the time available with the water and chlorine to carry out disinfection will be less. So in the second case, the velocity of flow, this velocity V2 will be more than the velocity of flow here, which is V1. So V2 will be more than V1. That is the first thing. If velocity is more than the time available to carry out disinfection, in the second case will be less than the time available in the first case. So when time available is less, so obviously you need to apply more amount of chlorine. Now sir, which law gives you the relation between time of disinfection and the concentration of disinfectant? So it is given by the Watson's law. So by Watson's law I can write down, by Watson's law I can write down T into C raised to power n is a constant. Means T1 C1 raised to power n is equals to T2 C2 raised to the power n. Now first of all, why I am not using N1 and N2 here? Reason is the type of microorganism is same, it is not different. That is why this N and N are same. In the question, the value of this N is also given to you as 1. So I will simply write down T1 C1 raised to the power 1 is equal to T2 C2 raised to the power 1. Okay, now one by one. How should I calculate this T1? This T1 is nothing but this length divided by V1. How to calculate this V1? V1 is nothing but discharge flowing through the pipe divided by area of the pipe. Okay, that is V1. Chalo, do this. So T1 is equals to L upon V1, and this C1 is the weight of chlorine applied per day, that is 32 kg per day, divided by the discharge Q1. So that will be your concentration. 32 kg per day is not the concentration. Concentration will be always weight per unit volume. That volume can be in meter cube, that volume can be in liters. So this is the concentration, weight of chlorine applied per unit volume, right? So 32 by Q1 will be the discharge, will be the concentration of chlorine applied in the first case. Similarly, let's do this second case. T2 is equals to length divided by V2 into concentration is equal to weight of chlorine applied in the second case divided by the discharge Q2. Okay. Please do solve this further. So this is equal to L upon V1 can be written as Q1 upon area of pipe into 32 by Q1. Don't solve anything as of now. Just keep adding the expression. Similarly, L upon V2 can be equal to Q2 divided by area of pipe into W2 by Q2. Now see this. L and L will cancel out. A and A will cancel out. So what you are left with? You are left with 32 by Q1 square is equals to W2 by Q2 square. Calculate this. So 32 by Q1 square is equal to W2 by Q2 square. Please do this calculation and tell me the answer. So W2 is equals to Q2 by Q1, the whole square, into 32. So W2 is equal to Q2 is 22, Q1 is 16, the whole square into 32. Please do this calculation. Piyush is answering 40.89 kg per day. Okay. Please solve this. So this will be 22 by 16 square into 32. So this will be 60.5 kg per day. So W2 will be 60.5 kg per day. Just all of you quickly confirm this. Yeah, this will be 60.5 kg per day, right? This will be your final weight of chlorine that you need to apply every day when your discharge has increased to 22 mld. Okay. It's a very good question, right? You can expect this kind of question in your examination. So moving ahead with this, let's try the next thing. Okay, now my dear, this finishes the first part of environment, that is your raw water engineering, in which we have discussed about, specifically about quality of water and the treatment of water. Those two are the very important areas from where you can expect a good quality question. Now next is your wastewater engineering. First of all, what do we read in wastewater engineering? In wastewater engineering, we read about collecting the wastewater, transporting this wastewater, doing the quality analysis of this wastewater using water quality parameters, and then giving the treatment to this wastewater, and finally the treated wastewater is disposed back to the source. The quality analysis of the wastewater is done using wastewater quality parameters. So all the wastewater quality parameters that we read in raw water engineering are common with wastewater engineering. Apart from this, in our wastewater, organic matter is present, because precisely we talk about municipal wastewater. Now this organic matter is of two types: biodegradable organic matter and the non-biodegradable organic matter. The amount of oxygen required to decompose both biodegradable and non-biodegradable organic matter is termed as chemical oxygen demand. And the amount of oxygen required to decompose only biodegradable organic matter is termed as biochemical oxygen demand, that is BOD. Okay. Certain formulas I have written. BOD 5 at 20 degrees Celsius is equals to initial dissolved oxygen minus final dissolved oxygen multiplied by the dilution factor. Dilution factor is the ratio of total volume of the diluted sample divided by the volume of original sample present in the diluted sample. So for example, if you have your water sample, say this is your water sample and the quantity of water sample is x ml. The quantity of this water sample is x ml. X ml is your waste water sample. Okay. Now this x ml of waste water sample is mixed with y ml of aerated water. This x ml of waste water sample is mixed with y ml of aerated water, right? So when you mix both of them, they will form a diluted sample. They will form a diluted sample like this. What will be the total volume of this diluted sample? The total volume of this diluted sample will be x plus y. The total volume of this diluted sample will be x plus y ml, is the total volume of this diluted sample. So if you have to calculate the ratio of, if you have to calculate the dilution ratio of this diluted sample, it is equal to total volume of the diluted sample divided by the volume of original sample, which is x, present in the diluted sample. So in this case, the dilution ratio will be x plus y divided by x. So dilution ratio is dilution ratio is x plus y divided by x. Total volume of the diluted sample divided by the volume of original sample present in the diluted sample. Okay, sir. Now, sir, BOD consumed is equals to ultimate BOD into 1 minus e raised power minus k into t. BOD consumed means the amount of BOD which is decomposed after time t. And BOD remaining simply means the amount of BOD which remains after time t. One more thing here, whenever I need to represent organic matter present in the wastewater, I represent it in terms of BOD. So BOD basically gives you an idea about how much amount of organic matter is present in the wastewater. Similarly, BOD consumed is also equal to BOD ultimate into 1 minus 10 raised power minus KD into T. So whenever you are using base 10, you have to use KD. If you are using base E, you have to use K. Similarly, BOD remaining after time T is equals to BOD ultimate into e raised power minus K into T. Similarly, BOD remaining is equals to BOD ultimate into 10 raised power minus KD into T. Okay. Now the value of this K and KD changes with temperature. So the value of KD at any temperature T is equal to the value of KD at 20 degrees Celsius multiplied by 1.047 raised to the power T minus 20. All those formulas that you have already read. Chalo, move ahead with this. Please try this question. Please tell me which of the following option is correct. Which of the following option is or are correct? It's a multiple select question. Have 1 minute of time. Just go for it. Go for it. Just tell me which option is correct. Out of this, which of the following option is correct? Just answer this quickly. Okay, so for answering this, keep this table in your mind. If I talk about organic matter, organic matter is of two types. You have biodegradable organic matter and you have non-biodegradable organic matter. The amount of oxygen required to decompose only biodegradable organic matter is termed as BOD. The amount of oxygen required to decompose only biodegradable organic matter is termed as BOD. Whereas the total amount of oxygen required to decompose both biodegradable and non-biodegradable organic matter is termed as COD. The total amount of oxygen required to decompose both biodegradable and non-biodegradable organic matter is termed as COD. So this is termed as COD. Now you can see which one is the bigger rectangle. So obviously the rectangle corresponding to COD is a bigger rectangle. In case if wastewater only contains biodegradable organic matter and no non-biodegradable organic matter is present, only in that case COD can be equal to BOD. But COD can never be less than BOD. So first thing that I know is COD is always greater than or equal to BOD. Right? Now which BOD I am talking about? I am talking about total BOD of the wastewater, which is termed as BOD ultimate. Right? BOD ultimate. So COD is greater than or equal to BOD ultimate. and we know that BOD5 is approximately 68% of BOD ultimate. BOD5 is BOD5 is approximately, I am saying BOD5 is 68% of BOD ultimate. Is 68%. Approximately I am saying 68%, not in every case. For a particular value of K, BOD5 is 68% of BOD ultimate. So BOD5 has to be always less than BOD ultimate. This means that COD will be always greater than BOD5. In every case, COD has to be greater than BOD5. So COD is always greater than BOD5. So option A is correct. Coming to option B, BOD5 is equals to COD, absolutely incorrect. BOD ultimate can be equal to COD when only biodegradable organic matter is present. Then BOD5 is greater than COD, absolutely incorrect. BOD5 is not equal to COD, again absolutely correct. BOD5 never equals to COD. BOD ultimate can be equal to COD if only biodegradable organic matter is present. So for this question, your option A and option D are the correct answers, right? Chalo, moving ahead with this. Okay, you can write this. These are like very important findings which will actually going to help you out. Okay, let's move ahead with this. Please try this next question. Question says that the following observations were made on 8% dilution of wastewater sample. Now sir, what is this 8% dilution? You know how I remember this? 8% dilution means in 100 ml of the diluted sample, 8 ml is wastewater. That is my way of remembering this. 8% dilution means out of total quantity of wastewater, 8% out of total quantity of diluted sample, 8% is wastewater. 8% dilution means 8% dilution means out of total volume of diluted sample, out of total volume of diluted sample, out of total volume of diluted sample, 8% is wastewater. 8% is wastewater means if V is the volume of diluted sample, if V is the volume of diluted sample, then what will be the volume of wastewater? So volume of wastewater will be volume of wastewater will be 8% of V. That will be the volume of wastewater. Now this dilution is given to you for calculating the dilution ratio. Why I am saying this? The initial DO of the diluted sample is 4.5 milligram per liter. DO of the diluted sample after 5 days of incubation is 1.2 milligram per liter. The 5-day BOD at 20 degrees Celsius is. Now sir, how to calculate 5-day BOD? So BOD 5 is equal to DO initial minus DO final multiplied by dilution ratio or dilution factor, right? So what is initial DO? Initial DO is given to you as 4.25 milligram per liter. 4.25 milligram per liter, and DO final is given to you as 1.2 milligram per liter. So this is 1.2 milligram per liter multiplied by dilution ratio. So for dilution ratio, the final volume of the diluted sample is V divided by the volume of wastewater present in the diluted sample is 0.08 times of V. So this will be the dilution ratio for 8% dilution of the sample. Please calculate this. So this will going to give you BOD 5. Please comment your answers. What is the value of BOD 5? Please comment your answers for BOD 5. All of you please do the calculation and comment your answer for BOD 5. So BOD 5 will be 4.25 minus 1.2 divided by 0.08. So this will be 38.13 milligram per liter. This will be 38.13. All of you just quickly confirm this, whether it is 38.13 milligram per liter or not. So this is 38.13 milligram per liter. All of you just quickly confirm this. Okay. So BOD 5 is 38.13 milligram per liter. Now try this question. Question says that the following observations are made on 12% dilution of the water sample. Okay, sir. So this time the dilution is given to you as 12%. Then they are saying that the initial DO of the diluted sample is 6.23 milligram per liter, and DO of the diluted sample after 5 days of incubation is given to you as 0 milligram per liter. 0 milligram per liter means it's a warning. You don't have to calculate BOD 5 whenever final DO is equal to 0. So BOD is not calculated whenever final DO is reported as 0. So you can answer this. BOD 5 is not calculated when DO final is 0. When DO final is 0 milligram per liter. Now sir, what is the possible reason for this? When you do 5 days of incubation, so basically in these 5 days of incubation, microorganism utilizes the dissolved oxygen to carry out the decomposition of organic matter. Now if dissolved oxygen final reported is 0, so there can be chances that this dissolved oxygen have been utilized even before the duration of incubation. Like this dissolved oxygen have not lasted for 5 days. This dissolved oxygen may be utilized after 2 days or 3 days. So if some more dissolved oxygen would have been there, those microorganisms could have carried out more decomposition. So whenever final DO is reported as 0, first of all BOD 5 is never calculated. Second, for such sample you have to increase the dilution and again perform the BOD 5 test. Okay. So for this case BOD 5 is not calculated. Moving ahead with this, next please try this question. Question says that following observations were made on a 4% dilution of the wastewater. So I will simply calculate first of all dilution ratio. So dilution ratio is, I am directly doing this time. So dilution ratio is equals to 4% dilution of wastewater means V divided by 0.04 V. So what is this? 1 by 0.04. So this will be 25. So dilution ratio is 25. Okay, sir. DO of aerated water used for dilution is 5 milligram per liter. DO of original sample is 0.8 milligram per liter. Now this original sample, they are talking about sample of wastewater. So sample of wastewater is mixed with the sample of aerated water to get the diluted sample. DO of diluted sample after 5 days of incubation is 1.2 milligram per liter. You need to calculate the ultimate BOD of the wastewater in milligram per liter, taking KD as 0.1 per day. Now check this out. You have this wastewater. This wastewater is mixed with aerated water. This wastewater sample is mixed with aerated water. The DO of wastewater is given to you as 0.8 milligram per liter. This is given to you as 0.8 milligram per liter. So this is DO of wastewater. I am writing this as DOS. And DO for aerated water, DOA, is given to you as how much? DOA is given to you as 5 milligram per liter. This is 5 milligram per liter, right? Now what you need to do is, when you will going to mix these two, you will get the diluted sample. So first thing is, you need to find out DO initial of this diluted sample. Now sir, how to do this? This is the diluted sample we have. This is diluted sample. This is diluted sample, right? Now the volume of diluted sample is not given to you. In fact, DO initial of this diluted sample is also not given to you. So if you cannot calculate BOD 5, you cannot use the expression for calculating out BOD ultimate. Now sir, how to do this? You can check this. DO of wastewater and DO of aerated water is given to you. By any means, if you can calculate the volume of these two things, you can take the weighted average for calculating DO of this mix, DO of diluted sample. So first of all, if the total volume of the sample is VML, so total volume of diluted sample is VML. How much amount of wastewater is present in this? So 4% dilution means 4% of V is the amount of wastewater. So volume of wastewater is 0.04 times of V. So what will be the volume of aerated water? So volume of aerated water is equal to 0.96 times of V, right? This is the volume of aerated water and this is the volume of wastewater. Now since you know the volume of these two things, you can take the weighted average of dissolved oxygen to calculate the DO of mix, initial DO of this diluted sample. So calculate this. So DO initial of diluted sample is equal to DO of sewage multiplied by volume of sewage plus DO of aerated water multiplied by volume of aerated water divided by volume of sewage plus volume of aerated water. Please calculate this. So this is equal to DO of sewage is how much? DO of sewage is 0.8. What is volume of sewage? It is 0.04. 0.04 times of V plus DO of aerated water is 5 and volume of aerated water is 0.96 times of V divided by 0.04 V plus 0.96 V. Calculate this DO initial. Please calculate this DO initial. So this will be 0.8 into 0.04 plus 5 into 0.96 So this will be 4.832 milligram per liter. So DO initial of the mix is DO initial of this diluted sample is 4.832 milligram per liter. This is DO initial of this diluted sample. Now DO final of the diluted sample is also given to you. DO final of the diluted sample is given to you as 0.8 milligram, the DO final of this diluted sample is given to you as 1.2 milligram per liter. So DO final is 1.2 milligram per liter. So DO final is 1.2 milligram per liter. So from here you can calculate your BOD5. So BOD5 is DO initial minus DO final multiplied by dilution ratio. So DO initial is 4.832. So this is 4.832 minus DO final, which is 1.2, into dilution ratio. Dilution ratio is, you have already calculated this dilution ratio, which is 25. Please calculate this BOD5. Please calculate this BOD5. So 4.832 minus 1.2 into 25. So this will be 90.8 milligram per liter. So BOD5 is 90.8 milligram per liter. Now once you know the value of BOD5, you can calculate the ultimate BOD by using the expression. So first of all, my dear students, this BOD5 is BOD consumed. Means in the 5 days, you can see the change in dissolved oxygen. This change in dissolved oxygen is happening because oxygen is getting utilized in decomposing the organic matter. So this BOD5 is basically BOD consumed in 5 days. So I will write down BOD5 consumed is equal to BOD ultimate into 1 minus 10 raised power minus KD into T, KD into 5, right? The value of KD is already given to you. BOD5 consumed, you have already calculated 90.8. So this is 90.8 is equal to BOD ultimate, you need to find out, into 1 minus 10 raised power minus KD is given to you as how much? KD is given to you as 0.1 per day. Please do this. This is 0.1 per day into 5. Please calculate this. So 10 raised power minus 0.5, 1 minus answer. So 90.8. So this will be 132.8 milligram per liter. So BOD ultimate is 132.8 milligram per liter. This is 132.8 milligram per liter. All of you just quickly confirm this, whether you are getting the same answer or not. Please do this. Kindly confirm this once. Kindly confirm this. Answer is fine. Okay. Let's move ahead with the next question. Try this. Have 2 minutes of time. Try this. Okay, it's a quality question. Go for it. Go for it, go for it. Okay. Question says that a 2% sewage sample in is distilled water was incubated for 3 days at 27 degrees Celsius temperature. After incubation, the dissolved oxygen depletion of 10 milligram per liter was recorded. The biochemical oxygen demand BOD rate constant at 27 degrees Celsius was found to be 0.23 per day to the base E. The ultimate BOD in milligram per liter of the sewage will be. Now you can see here, this time the incubation is carried out at 27 degrees Celsius and the duration is 3 days. And directly the depletion in oxygen means the difference between initial and final dissolved oxygen is given to you as 10 milligram per liter. So this time if you apply this expression, BOD duration of incubation is 3 days and temperature of incubation is 27 degrees Celsius. This is equal to DO initial minus DO final into dilution ratio. So this time the direct difference is given to you as 10 milligram per liter. Okay. And this dilution ratio can be calculated by this 2% sewage sample. So BOD3 at 27 degrees Celsius is equal to BOD3 at 27 degrees Celsius is equal to 10 into 100 by 2. Dilution ratio will be 100 by 2, right? Please do this. So this will be 1000 by 2. So this will be, I think, 500 milligram per liter. So BOD3 at 27 degrees Celsius is 500 milligram per liter. Now you need to find out BOD ultimate. So please keep a check. This BOD3 is BOD consumed. This is BOD consumed in 3 days. This is BOD consumed in 3 days. Now, how to use this expression? Sir, for calculating ultimate BOD, I will use this expression. So, BOD3 consumed is equal to BOD ultimate into 1 minus e raised power minus K27 into 3. K27 is already given to you in the question, right? So, BOD consumed you have calculated as 500. This is equal to BOD ultimate into 1 minus e raised power minus K27, which is I think given to you as K27 is given to you as 0.23 per day. So, this is 0.23 into 3. Please find out this BOD ultimate. Please calculate this BOD ultimate. So, this will be e raised power minus 0.23 into 3. So, this will be 1003 milligram per liter. Please confirm this, whether you are getting the same answer or not, BOD ultimate. So, this is 1003 milligram per liter. This is your BOD ultimate, right? So, BOD ultimate is 1003 milligram per liter. Chalo, moving ahead with this next question. Try this. Question says that BOD5 of a wastewater has been measured as 700 milligram per liter. BOD5 of the wastewater is measured as 700 milligram per liter. If KD is 0.1 per day to the base 10, what percentage of BOD ultimate will remain unoxidized after 30 days? Means they are asking the percentage of BOD remaining after 30 days. So, what they are asking is, they are asking BOD remaining after 30 days by BOD ultimate into 100. This is what they are asking. This is the percentage of BOD unoxidized after 30 days. Chalo, let's do this. So, I know this BOD remaining after 30 days is equal to BOD ultimate into 10 raised power minus KD into 30. Okay. Do I know the value of KD? Yes, I know the value of KD. It is 0.1 per day. So, simply take this BOD ultimate here. So, you have BOD remaining after 30 days by BOD ultimate is equal to 10 raised power minus 0.1 into 30. Please calculate this. So, 10 raised power minus 0.1 into 30. So, this will be 0.001. This will be 0.001. Now, you can calculate the percentage from here. So BOD 30 remaining by BOD ultimate into 100 is equal to 0.001 into 100. So that is equal to 0.1 percentage. So 0.1 percentage of BOD ultimate will be unoxidized even after 30 days. So this is how you need to approach the question. So moving ahead with this, try this next question. The question says that in a certain situation, wastewater discharged into a river mixes with the river water instantaneously and completely. So a wastewater is discharged into a river stream which is getting mixed instantaneously. The following data is available. DO of wastewater is 2 milligram per liter and discharge of wastewater is 1.1 meter cube per second. Then DO of river water is 8.3 milligram per liter and discharge of river water is 8.7 meter cube per second. Then they are saying temperature is 20 degrees Celsius. Initial amount of dissolved oxygen in the mixture of wastewater and the river shall be. Now, my dear, it is very simple. You have to find out DO of mix. So, DO of mix is equal to DO of river multiplied by discharge of river plus DO of sewage multiplied by discharge of sewage divided by discharge of river plus discharge of sewage. So all the values are given to you. You have to simply substitute to calculate this DO of mix. Okay, please do this. So DO of mix is equal to DO of river is 8.3 milligram per liter. Discharge of river is 8.7 meter cube per second. Then you have DO of wastewater 2 milligram per liter and discharge of wastewater is 1.1 meter cube per second. So this is 1.1 meter cube per second divided by discharge of river which is 8.7 and discharge of sewage which is 1.1. So divided by 8.7 plus 1.1. Please do this. So this will be how much? 8.3 into 8.7 plus 2 into 1.1 divided by 8.7 plus 1.1. So the answer will be 7.593 milligram per liter. So DO of mix is 7.593 milligram per liter. This is DO of mix. So DO of mix is 7.593 milligram per liter. This is how you need to solve this question. It was a GATE 2 marks question in 2005. Okay, let's move ahead with this. So I think your option C is matching here, 7.6. Yeah. Moving ahead with the next question, try this. The theoretical oxygen demand of 0.001 mole per liter of glucose solution is. Usually, whenever any chemistry is involved, student starts feeling like very uncomfortable in these scenarios. So, how to calculate theoretical oxygen demand? If you know the chemical formula of the organic matter, you have to write down the oxidation equation of that organic matter, and then you need to apply the mole concept. So right now, what is the organic matter? Glucose is the organic matter. Check this out, how easily I can write down this oxidation equation. So glucose is C6H12O6. It reacts with oxygen, means the oxidation of glucose will lead to the formation of carbon dioxide and water will lead to the formation of CO2 plus H2O. Now, sir, you have to first balance this equation. So, for balancing, I think here it will be 6, here it will be 6, and here also it will be 6. So, this is the balanced equation. So, what you need to do for calculating theoretical oxygen demand, the first thing is write down the oxidation equation of the chemical or of the organic matter which is given to you. Now, you have to apply the mole concept. So, what does mole concept says that? You can see this is glucose. So, 1 mole of glucose will consume 6 moles of oxygen. So, 1 mole of glucose, 1 mole of glucose requires 6 moles of oxygen. Requires 6 moles of oxygen. Now, check this out. 0.0001 mole of glucose will require how much amount of oxygen? That you need to find out here. So, 0.001 mole of glucose, 0.001 mole of glucose will require 0.006 moles of oxygen. Moles of oxygen, and this much mole of glucose is present in 1 liter of water. So, this much amount of oxygen will be required by 1 liter of water. Okay. So, this many moles of glucose, this many moles of glucose will require this many moles of oxygen. Now, you have to simply calculate the weight of this many moles of oxygen, and that will be your theoretical oxygen demand. So, theoretical oxygen demand THOD is equal to number of moles of oxygen required, which is 0.006 multiplied by the molecular weight of oxygen. So, molecular weight of oxygen is 16 into 2, and this will going to give you the answer in gram per liter. Please calculate this. Kindly give me this theoretical oxygen demand. Please tell me the value of this theoretical oxygen demand. So, 0.006 into 32. So, this will be 0.192 gram per liter. Now, convert this into milligram. So, this will be 192 milligram per liter. This is the theoretical oxygen demand of this water sample. Let's check this out. So, your option B is the correct option. It was a GATE 2 marks question asked in the year 2002. So, 192 milligram per liter was the theoretical oxygen demand, right? So, this is how you need to proceed. Let's move ahead. Okay, please try this question. Question says that a wastewater stream having a discharge of 3 meter cube per second, ultimate BOD of 80 milligram per liter is joining a small river having a flow of 11 meter cube per second and ultimate BOD of 8 milligram per liter. Both the streams get mixed instantaneously. Cross-sectional area of the river is 60 meter square. Assuming K is 0.5 per day to the base E, the BOD in milligram per liter of the river 25 kilometers downstream of the mixing point is. A very interesting question. They are saying what is the BOD of the river in milligram per liter 25 kilometers downstream of the mixing point is. Now, usually students have many type of confusion ki sir, which BOD is this? My funda is, if nothing is mentioned, treat this as BOD consumed. If nothing is mentioned, treat this as BOD consumed. Okay. Ideally, it has to be BOD remaining. Ideally, it has to be BOD remaining. But when you see the solutions given by these question papers over the years, in some years they have considered this as BOD remaining. In some years they have considered this as BOD consumed. Okay. My thing will be, if nothing is mentioned, consider it as BOD consumed. As simple as that. Okay. You can take that kind of risk. So basically what is happening here is, this is a river stream. In this river stream, sewage is getting mixed here. So this is your river stream. In this river stream, sewage is getting mixed. And now from this section onwards, you have a mix. What they are asking is, when the water flows 25 kilometers downstream, when the water flows 25 kilometers downstream, what is BOD remaining, BOD consumed? What is BOD consumed after some time t, in which the water has reached from this point to this point? Okay. Now, sir, what we need to do here is, first we need to find out BOD ultimate of the mix. And then we have to find out how much time river will require to flow from this section to this section, that is a distance of 25 kilometers. So first I will find out BOD of mix is equal to BOD ultimate of river, BOD ultimate of river multiplied by discharge of river plus BOD ultimate of sewage multiplied by discharge of sewage divided by discharge of river plus discharge of sewage. Please calculate this. So BOD ultimate of mix is equal to, BOD ultimate of river is how much? BOD ultimate of river is, this is 4 milligram per liter and discharge is 11 meter cube per second. So 4 into 11 plus BOD ultimate of sewage is 80 and discharge is 3. So 3 into 80 divided by discharge of river 11 plus discharge of sewage, which is 80. Please do this and calculate BOD ultimate of mix. So 4 into 11 plus 3 into 80 divided by 91. So this will be 3.121 milligram per liter. This is BOD ultimate of mix, right? Now just calculate in how much time water will reach from this section to this section. So time required will be equal to length, which is 25 kilometers, divided by discharge of mix, okay, length divided by velocity. So do I know the value of velocity? No. But I know the total discharge of this mix and I'll know the cross-sectional area of flow. So I will write down time required is equal to length divided by discharge by cross-sectional area. So what is discharge of mix? Discharge of mix is equal to discharge of river plus discharge of sewage stream. So discharge of river is given to you as 11. Discharge of, one second. These are not the discharges, or these are the discharges. Four into 11, and this is, I should write 3 here. This will be 3. Sorry. Discharge of the sewage is 3. Please correct this. So you have 4 into 11 plus 3 into 80 divided by 14. So this will be 20.29 milligram per liter. Sorry. This will be 20.29 milligram per liter. Now you can calculate discharge of mix. So discharge of mix is equals to discharge of river plus discharge of sewage. That is 14 meter cube per second. Cross sectional area is also given to you. Cross sectional area of the river is 60 meter square. So area is 60 meter square. You can calculate velocity of flow. So velocity is equals to discharge of mix by cross sectional area. So that is equal to 14 by 60, and this will come out in meter per second. Please calculate the time in days because the value of K is given to you in days. Okay. So time T is equal to length. Length is 25 kilometer. So 25 into 1000 divided by 14 by 16. This area is 60. Why I am writing 16 here? So 40 by 60 into 3600 into 24. So now this velocity will be in meter per day. This length will be in meter. So time will come out in days. Please calculate this. So 25 into 1000 into 60 divided by 14 into 3600. So this will be 1.24 days. Time is coming out as 1.24 days. Now once you know the value of time, you can calculate BOD remaining. Sorry, BOD consumed. So BOD consumed in time T. So BOD in time T is equals to BOD ultimate into 1 minus the value of K air. Value of K is given to you as 0.25 per day. So 10 e raised to the power minus 0.25 into T. Substitute all the values. So BOD after time T is equal to BOD ultimate of the mix, which is 20.29. So this is 20.29 into 1 minus e raised power minus 0.25 into time T. So time T is 1.24 days. Just calculate this. So this will be 5.408. So BOD after time T is 5.408 milligram per liter. This is BOD after time T. Please have this. So BOD after time T is 5.408 milligram per liter. Okay, let's move ahead with this. Okay, sir. After this, we have seen a lot of questions from BOD and we have also seen some questions from the disposal of the sewage, right? Now, next is your design of sewers. My dear, for design of sewers, first thing is sewers are designed to carry maximum discharge, but they are also ensured, but one thing is also ensured that corresponding to minimum discharge, the development of self-cleansing velocity should take place inside the sewer. This self-cleansing velocity does not allow the solids to settle when the sewage is flowing inside the sewer. Okay. The expression for self-cleansing velocity is under root 8k by f g minus 1 into gd, where f is the friction factor, d is the size of the particle, k is a constant depending upon the type of particle. Then you have the hydraulic properties of flow in the sewer. So the ratio of depth of flow for the sewer running partially at partial depth to the sewer running at full depth. So small d by capital D is equals to 1 minus cos alpha by 2 whole divided by 2. Ratio of perimeter small p by capital P is equals to alpha by 360. Ratio of area of flow small a by capital A is equals to alpha by 360 minus sin alpha upon 2 pi. The ratio of hydraulic mean depth for the sewer running at partial depth and the sewer running at full depth. So small r by capital R is equals to alpha by 360 minus sin alpha upon 2 pi divided by alpha upon 360. The ratio of velocity of flow small v by capital V is equals to alpha by 360 minus sin alpha upon 2 pi divided by alpha by 360 raised to the power 2 by 3. So these are some of the hydraulic properties of the sewer that you should remember. Then for sewers having same degree of self-cleansing means the tractive stress applied by the sewer on the settled solids is same. That is what we mean by sewers with same degree of self-cleansing. For the sewers having same degree of self-cleansing, the ratio of velocity of flow small v by capital V is equals to small r by capital R raised to the power 1 by 6. Okay, sir. Next thing is you have this question which says that a sewer of 400 mm diameter and the slope is 1 in 800 mm is running half full, has a velocity of flow of 1.64 meter per second. Check this out. So say this is the sewer and this sewer is running half full. This is the sewer which is running half full, right? The sewer of 400 mm diameter, the size of the sewer is given to you as 400 mm. And this depth of flow so this is the depth of flow small d. So depth of flow small d is equal to 400 by 2. That is equal to 200. Slope of the sewer S is given to you as 1 in 800. So 1 by 800. Then you have is running half full having a velocity of 1.64. So small v is given to you as 1.64 meter per second. What velocity of flow will be obtained if the slope is made 1 in 200? What velocity will be obtained if the slope is made 1 in 200? So velocity V1 is 1.64 for the slope of 1 in 800. If the slope is increased to 1 in 200, then what will be your velocity of flow V2? This is asked. Okay. It's a simple question of Manning's equation. By Manning's equation, we know that by Manning's equation, we know that velocity of flow is equal to 1 upon n into r raised to power 2 by 3 into s raised to the power 1 by 2. So you can simply take the ratio of V1 by V2 and you can just write down the value of S. Since the depth of flow is not changing, therefore the value of R will not change. Since the material of sewer is not changing, therefore the value of N will not change. So we can take the ratio of V1 by V2, which is equal to, so V1 by V2 is equal to 1 upon N into R raised to power 2 by 3 into S1 raised to the power 1 by 2 whole divided by 1 upon N into R raised to power 2 by 3 into S2 raised to power 1 by 2. Okay. So you can check this out. 1 by N will cancel out. R and R will cancel out. You can simply take the ratio of V1 by V2 to calculate the value of V2. Please do this calculation. So V1 is given to you as how much? V1 is 1.64. And what is V2? V2 you need to find out. This is equal to S1 by S2 the whole square. Sorry, S1 by S2 whole raised to power 1 by 2. So this is equal to S1 is 1 in 800 and S2 is 1 in 200. So when you do it, it will be 2 by 800 raised to the power 1 by 2. Please solve this. So V2 will be equal to 1.64. So this will be 1 by 4. Square root of 1 by 4 will be, square root of 4 will be 2, right? So you need to multiply 2 here. So 1.64 into 2. So please calculate this V2. So V2 will be 1.64 into 2. So that will be 3.28. So the value of V2 is 3.28 meter per second. This is the value of V2. So V2 will be 3.28 meter per second. This is how you need to solve this type of sewer type of question, okay? Using the Manning's equation. Always remember that if the depth of flow is not changing, hydraulic mean depth will also not going to change. Hydraulic mean depth is the ratio of wetted area to wetted perimeter. So if depth of flow is not changing, means this wetted area is not changing and this wetted perimeter is also not changing. Okay, let's move ahead with this. Try this next question. Question says that in a circular sewer of diameter D, if the depth of flow is D by 4, then what is the wetted perimeter? So depth of flow, small d, is given to you as D by 4. Then what will be the wetted perimeter? Check this out. So when you see this expression, we have taken the ratio that small d by capital D is equal to 1 minus cos alpha by 2 divided by 2. So I will use this and I will calculate the value of alpha. So small d by capital D is first of all equal to 1 by 4, which is 1 minus cos alpha by 2 whole divided by 2. Okay. From here calculate the value of alpha. So this will be 1 by 2. So 1 by 2 is equals to 1 minus cos alpha by 2. So I will write down cos alpha by 2 is equal to 1 by 2. Now this is nothing but cos 60 degrees, right? This 1 by 2 is nothing but cos 60 degrees. So I will write down alpha by 2 is 60 degrees. So alpha will be equal to 120 degrees. So you have calculated alpha as 120 degrees. Now sir, you need to find out the wetted perimeter. So for wetted perimeter, we have another ratio, small p by capital P. What it is equal to? Small p by capital P. We have seen this relation here. Small p by capital P is equals to alpha by 360. Small p by capital P is equals to alpha by 360. What is the value of alpha? Alpha is 120 degrees. So this will be 120 by 360. So small p is equal to capital P into 1 by 3 and capital P is nothing but pi d. Small p is equals to pi d by 3. Capital P is the perimeter, wetted perimeter when the sewer is running at full depth. So when the sewer is running at full depth, you have to consider the entire perimeter of the sewer. So P is equals to pi d by 3. So again, it is a very basic question from this sewer, but again an important one, because it is using two formulas. This is the second one and this is the first one. Two important formulas it is using. That is why it becomes again an important question here. Chal, let's move ahead with this. Try this next question. The question says that a sewer having a diameter of 400 mm and slope of 1 in 600 while running full, it has a mean velocity of 0.9 meter per second. If both the diameter and slope are doubled to respectively 800 mm and 1 in 300, what will be the change in mean velocity when running half full? So first observe this case number 1. When the diameter of the sewer is 400 mm, slope is 1 in 600 while running full. This time it is running full. Okay. So first scenario, case 1. When the sewer is running full. This is when the sewer is running full. When your sewer is running full, the diameter of the sewer is given to you as 400 mm. Okay. So first of all, calculate the hydraulic mean depth for this sewer. So hydraulic mean depth for this sewer, R1, is equal to wetted area upon wetted perimeter. Upon wetted perimeter. So R1 is equal to wetted area is pi by 4 into D square. So D is 400 square. And wetted perimeter is pi D. So pi into 200. So pi and pi will cancel out. Calculate the value of R1, pi D. R is 4. Sorry, D is 400. So this will be 400 by 4. So R1 will be 100. So first thing that you have calculated is the hydraulic mean depth of first case, right? Now you can use the Manning's expression and write down the expression for V1. So by Manning's equation, I can write down V1 is equal to 1 upon N into R1 raised to the power 2 by 3 into S1 raised to the power 1 by 2. Just write down the expression and leave it. Okay. So V1 is given to you as how much? 0.9 meter per second. So V1 is 0.9, which is equal to 1 upon N. R you have calculated as 100 raised to the power 2 by 3. And S1 is how much? S1 is 1 in 600. So 1 in 600. So 1 by 600 raised to the power 1 by 2. So this is the expression for V1. Okay. This is the expression for V1. Now in second case, both diameter and slope is doubled. So now the new diameter will be 800 and slope will be 1 in 300. So case 2 is both slope and diameter is doubled. So when slope and diameter is doubled, and in this case, the sewer is running half full. This will be the depth of flow. this is the new second case where the size is doubled and sewer is running half full. So what will be the depth of flow? Small d, depth of flow will be equal to the size of this sewer, which is 800 mm. So this will be 800 by 2. So small d will be equal to 400 mm. Okay, sir. So I can write down small d by capital D is equal to 1 by 2, which is equal to 1 minus cos alpha by 2 whole divided by 2. Get me the value of alpha. So this is equal to 1 is equal to cos of alpha by 2. So cos 0 is 1, right? So the value of alpha will come out as 180 degrees. So the value of alpha is 180 degrees. The value of alpha is coming out as 180 degrees. Okay, sir. Now you can calculate the value of R. So you can use this expression of R for calculating R. You have alpha upon 360 minus sine alpha upon 2 pi by alpha upon 360. Or instead, what can be done here is, instead of using this alpha, I can write R2 is equal to A2 by P2. Now what is A2? A2 is total area, half of that total area. So this is pi into 800 square by 4. And similarly, P2 is half of total perimeter, that is pi into 800. So that can be the value of R2. Instead of calculating alpha, you can directly use this. So I can remove this. Let it be. So what will be the value of R2? Just calculate this R2. So this half and half will cancel out. This pi and pi will also cancel out. 1/800 will cancel out with 1/800. So now you have 800 by 4. So that is 200. So the value of R2 will be 200. So you can use this expression. V2 is equal to 1 upon n into R2 raised to the power 2 by 3 into S2 raised to the power 1 by 2. Okay. Apply all the things. V2 you need to find out is equal to 1 upon n into 200 raised to the power 2 by 3 into slope 1 in 300 raised to the power 1 by 2. Now simply take the ratio of V2 by V1 to get the value of this V2. Simply take the ratio of V2 by V1 to get the value of V2. Please do this. So V2 by V1 is equal to 1 upon n into 200 raised to the power 2 by 3 into 1 by 300 raised to the power 1 by 2 whole divided by, what is V1? V1 is 1 by n into 100 raised to the power 2 by 3 into 1 by 600 raised to the power 1 by 2. Substitute the value of V1. Get me the value of V2. Yeah, thank you, Richa. Substitute the value of V1 and get me the value of V2. V1 is how much? V1 is given to you as 0.9 meter per second. Please do this. So this 1 by n and 1 by n will also cancel out. Okay. So when you see here, this will be 2 raised to the power 2 by 3 and this will be again 2 raised to the power 1 by 2. So I have this expression, V2 by 0.9 is 2 raised to the power 2 by 3 into 2 raised to the power 1 by 2. You can add them. So you have V2 is equal to 0.9 into 2 raised to the power 2 by 3 plus 1 by 2 will be how much? So this will be 4. 4 plus 3, 7. So this will be 7 by 6. Please calculate this. Sir, I missed my correction date for the application of 20th November, but today I submitted it. Will it be accepted? Application is accepted. Your corrections are accepting. You have submitted it. Your corrections are accepting. Because if the window would have been closed, you may not able to submit. If you are able to submit it, means the dates have been extended. So V2 is equals to 0.9 into 2 raised to power 7 by 6. Please do this. V1 is 0.9, yeah. So 2 raised to the power 7 by 6. Into 0.9. So this will be 2.02 meter per second. So V2 will be 2.02 meter per second. This is how you need to deal with this question. Okay. It says it is under scrutiny. I have submitted it, sir. Yeah, they will. If it is under scrutiny, then you need not to worry about anything. Okay. So V2 is 2.02 meter per second. Chalo. Let's move ahead with this question. Next question is this, right? A very important question asked in the year 2023. What the question says that a system of 7 river segments is shown in the schematic diagram. So this is a system of river segments which is shown. Okay, their corresponding flow rates and concentration of a conservative pollutant respectively is also mentioned. Assumed complete mixing at the intersection, no additional water losses or gain in the system and the steady state condition. Given Q1, Q2, Q2, Q4, Q6 and C1, C2, C6 concentration of this is given to you. You have to find out what is the pollutant concentration in this river segment 7. Okay. Now you can see this. There are 2 segments of river R1 and R2 which are meeting and forming a river segment R3. You have 2 river segment. This is river segment R1 and this is your river segment R2. They are meeting together to form this river segment R3. Okay, sir. This is river segment R1 and this is river segment R2 and this is river segment R3. So now if I give you the discharge of river segment 1 and discharge of river segment 2, simultaneously if I give you the concentration of river segment 1 and 2, can you calculate the value of discharge of this river segment 3? And can you also find out the concentration of the pollutant in this river segment 3? The answer is yes. Check this out. So discharge Q3 is equal to Q1 plus Q2. The value of Q1 and Q2 is given to you. Q1 is 5 meter cube per second and Q2 is 15 meter cube per second. So this will be 5 plus 15. So the value of Q3 will be equal to 20 meter cube per second. So this will be 20 meter cube per second. This is Q3. Now next, the concentration of pollutant in this river segment 3 can be calculated by the expression C3 is equal to C1 Q1 plus C2 Q2 divided by Q1 plus Q2 divided by Q1 plus Q2. You know all the values. Calculate the value of C3 and comment it. So C3 is the concentration of pollutant in river segment 3 and Q3 is the discharge in this river segment 3. Please do the calculation for C3. So C3 is equal to, C1 is how much? C1 is given to you as 8 kg per meter cube and C2 is 12. C1 is 8, Q1 is 5, C2 is 12, Q2 is 15 divided by 5 plus 15. Let me just cross check this again. Yeah, C1 is 8 and C2 is 12. Okay, sir. Calculate this C3. So the value of C3 will be 8 into 5 plus 12 into 15 divided by 20. So this will be 11 kg. What is the unit of concentration? 11 kg per meter cube. This is 11 kg per meter cube. This is the value of C3. Now check this out. In the further river segment, they have said that in C3, this R3 is, from this R3, R4 and R5 are getting separated. So from this R3, R4 and R5 are moving out. So basically R4 is moving out and then R5 is continuing like this. This is R5. This is R5 and this is your R4. Here the major mistake that student made in attempting this question is, you have to understand, my dear, the concentration will not going to change if the river is separated. The concentration will only going to change if the rivers are getting mixed together. Then only the dilution will going to change the concentration. But if the rivers are getting separated, the concentration will not going to change. Here the concentration is C3, same concentration will be C5 and same concentration will be C4. Means your C5 will be equal to C3 and C4 will be also equal to C3. When the rivers are separating out, concentration will not change. Discharge of both these rivers will going to change. So now for that, you are given with the discharge of river 4. So discharge of river 4 is 3 meter per second. So Q4 is 3 meter per second. Q4 is 3 meter cube per second. So I can write down Q3 is equals to Q4 plus Q5. Q3 is equal to Q4 plus Q5. You know the value of Q3, which is Q3 is how much? Q3 is 20. So Q3 is 20. Q4 is how much? Q4 is given to you as 3 and Q5 you can calculate from here. So Q5 will come out as 17 meter cube per second. So Q5 will come out as 17 meter cube per second. This is the value of Q5. Okay. Now once you got the value of Q5, you got the concentration of C5. So what will be the concentration of C5? C5 is equals to C3. So C5 is equal to C3. And what is C3? C3 is 11 kg per meter cube. Now in this C5, one more river segment is getting added, that is C6. And it is forming a river segment 7. This river segment 6 is getting added into river segment 5 and forming the river segment 7. This is your river segment 6 and this is your river segment 7. The concentration will only going to change when the river segments are added together. If the river segments are flowing out, then the concentration will not going to change. Okay. Please find out this. So this, first of all, discharge of 7 is equals to discharge of 5 plus discharge of 6. Calculate this value. So Q5 is 17 and Q6 is given to you. Q6 is 8. Q5 is 17 and Q6 is 8. So this will be how much? This will be 25 meter cube per second. Then next you have C7 that you need to find out. So C7 is nothing but C5 into Q5 plus C6 into Q6 divided by Q5 plus Q6. So C7 is equals to C5 into Q5. C5 into Q5 plus C6 into Q6 divided by Q5 plus Q6. Chalo, do this. So this is equal to C5 is how much? C5 is 11. What is Q5? Q5 is 17. What is C6? C6 is given to you as 10 kg per meter cube. This is 10. And what is Q6? Q6 is 8 divided by 17 plus 8. You can do this calculation and get the value of C7. Please do this. So this is 11 into 17 plus 10 into 8 divided by 17 plus 8. So that will be 10.68. C7 will be 10.68 kg per meter cube. So this will be 10.68 kg per meter cube. That is the value of your C7, right? The concentration which is required is C7. Okay. Let's see this ahead. After this, my dear, after this comes the treatment of wastewater. So the treatment of wastewater comprises of these following things. It starts from the pre-treatment, where first we do screening, then we go with the comminators and macerators, which basically grind the coarse suspended solids into the lighter ones. And then in India, we don't go with the unit which is termed as skimming tanks. So basically in European countries, skimming tanks is used. A skimming tank is a unit to remove oil and grease from the wastewater. In India, instead of using skimming tanks, we go with vacuators for removing this oil and grease. Reason why skimming tank is not used in India? Reason is very simple. In skimming tank, basically we provide the compressed air from the bottom, and when this compressed air moves from the bottom to the top, it agglomerates the oil and grease particles together. In India, whatever temperature range that we have, which lies in the range of 10 to 25 degrees Celsius, at such a high temperature, this agglomeration of oil and grease particles is very difficult. It does not take place efficiently. That is why in India, skimming tanks are not used. We go with vacuators. One more additional information here. In order to increase the efficiency of skimming tank, we apply chlorine along with the compressed air. Okay, sir. So in pre-treatment, first one is the use of screen. Screen removes coarse suspended solids. Then you have grit chamber. Grit chamber basically removes inorganic suspended solids. After grit chamber, you have skimming tank that removes oil and grease. That is your pre-treatment. Then you have primary treatment. So primary treatment basically removes organic suspended solids, and then you have the secondary treatment, which is also termed as biological treatment, which is strictly used to remove organic dissolved solids. We have four different types of solids, right? First one is inorganic suspended solids, inorganic dissolved solids, 2. Third is organic suspended solids, and fourth one is organic dissolved solids. Inorganic suspended solids are removed by grit chamber, and all the types of coarse suspended solids are already removed by the screens. Organic suspended solids is removed by primary treatment. Now we are left with two of them: dissolved inorganic solids and dissolved organic solids. If we are treating industrial water, then we will be worried about dissolved inorganic solids, and we will going to give the tertiary treatment. So third degree treatment is capable of removing inorganic dissolved solids. But for municipal treatment, inorganic dissolved solid is not a major impurity, right? We have organic solids as the major impurity. So we are more worried about removing organic dissolved solids, which is removed by this secondary treatment. In secondary treatment, basically microorganisms carry out the decomposition of the organic matter, and the biomass formed is settled out in the secondary sedimentation tank. So biological treatment unit, namely trickling filters, you have rotatory biological contractors, activated sludge process, upflow anaerobic sludge blanket reactors, septic tanks, IMOF tanks, oxidation ponds. All these, any of them is used, any one of them is used in the biological treatment plant. So this biological treatment unit along with secondary sedimentation tank, combinedly they are known as secondary treatment. Now you can see here in this diagram, a sludge is generated from three major areas. First one is the grit chamber. So whatever sludge is produced in the grit chamber, it contains inorganic suspended solids. This sludge is not a very harmful sludge because this sludge will not cause any unsanitary condition. So a sludge obtained from the grit chamber can be simply dried and it can be used for the filling purposes. Second, the second area from where sludge is produced is the primary treatment, from the primary sedimentation tank. Now this sludge contains undecomposed organic matter, and if this undecomposed organic matter is left out in open, it will attract microorganisms from all the sides and it leads to the development of unsanitary condition where this untreated sludge is disposed. So this is the most critical sludge, that is why the name given is raw sludge, because the organic matter is not decomposed in this primary treatment, right? Third area from where the sludge is produced is the biological treatment. Now usually whatever sludge that we get from the biological treatment, it is already decomposed to a certain degree. So although it is harmful, but again it is not that much harmful as compared to the sludge produced by the primary treatment. So usually in order to have the controlled decomposition, the sludge from the primary treatment is decomposed in the absence of oxygen, and that unit is termed as sludge digestion. So when you decompose the sludge in the absence of oxygen, that unit is termed as sludge digestion. Whatever sludge that we get from the secondary sedimentation tank, that sludge can be digested in the presence of oxygen and it will not going to create so much harm to the system. Okay. Moving ahead with this. So here you have different types of settling. You already know we have 4 different types of settling based on the concentration of the suspended solids. First is called as type 1 or discrete settling. So if the settling of the solids is not affecting the settling of other solids, then it is termed as discrete particle settling. This type of settling is observed in plain sedimentation tank and in the grit chamber. The second type of settling is called as flocculent settling. When during settling, the shape and size of the suspended solid changes. So this happens usually in the flocculation tank, where this sticky precipitates absorbs all the fine suspended solids over its surface and it grows in size to form larger flocks. And then when it settles, that type of settling is called as flocculent settling. Whatever expression of settling velocity we have derived, it is only applicable for discrete particle settling. It is not applicable for any of these settlings remaining. Okay. Then you have zone settling. So when the particle is settling and the concentration is so large that the velocity field around the settling particle overlaps with each other, means when the particle will going to settle, the turbulence which is caused around the particle is called as velocity field. If the concentration of the particle is so large that the velocity field of two settling solids overlaps each other, then they settle in the form of zone. That is why the name given is type 3 or zone settling. The fourth type of settling is compression settling. So if the concentration of the particles is so large that the lower layer of the solids starts supporting the upper layer and the upper layer compresses the lower layer such that the water squeezes out from the voids, then that type of settling is called as compression settling. So basically this type 3 or zone settling is observed in secondary sedimentation tank after activated sludge process, and this type 4 settling is observed in the secondary sedimentation tank after trickling filter. Okay sir, so these are the different types of settling. Then next we have this question we have for sludge digestion. My dear, the time of the session is from 6 to 9, right? Whatever was there in my end, the maximum that I could cover in this 3 hours, I have done it. I will provide this PDF in the Telegram group. So again, the link of the Telegram group is given to you in the description box. Kindly join the link of this Telegram group and you will get this PDF. So whatever 5-6 questions are remaining, you can try using this PDF. In case if you are doubtful, you can just text me and I will provide you the solution for that also, right? But whatever questions I have listed here in this PDF are very important questions. So try to attempt those questions, okay? So the link of the Telegram group is given to you in the description box. You can join our Telegram group for enjoying the free quizzes. We also provide you the lecture PDFs of these GATE score booster sessions in the same Telegram group. Now few announcements before I just close this session, my dear. We at IMS GATE Academy, we provide you with 800 hours of live teaching with interaction and doubt solving. We provide you with theory and exercise book containing 4,000 practice questions well versed in level 1, level 2 and level 3. Along with that, we provide you with 33 years of GATE question bank containing detailed solution, alternate solution, video solution and key points and chapter overview. Along with that, we provide you with 12 personalized one-to-one mentoring sessions termed as My Plan Sessions, which is a flagship program conducted by IMS GATE Academy to keep their student motivated, oriented and well focused towards their GATE preparation journey. Along with that, we provide you with India's largest test series in which we provide you with 130 plus tests. From this year onwards, we have launched one more program which is called as Test Series Plus. And right now the best thing is you can avail this program at a discounted price of 20%. You don't have to use any code. Directly, you can book a free counseling session for which the link is provided to you in the description box and you can avail this offer of 20%. So that is all what I have to offer you for environment. I hope every question that we have discussed here will going to help you in revising the content through the numericals. So this was the first 2 sessions of environmental engineering. On 26th and 27th of November, I'll be back with the 2 sessions of strength of material where we will be discussing those critical questions which will help you to revise all the concept of all the chapters. So thank you so much, my dear students, for listening patiently, answering well and keeping your energy high, which has literally motivated me. Thank you so much for being such a great student. I wish you all the best in the upcoming GATE examination and never forget to revise, practice and analyze your preparation and keep improving with a spirit of getting a rank, not just qualifying the exam. I wish you all the best. This is your mentor Prateek Mishra signing off with a smile. Please take care.